Hi students, we are going to discuss about the case study on energy efficiency on a domestic pressure cooker. Shahana, please share about.
Today our team is presenting a case study based on improving energy efficiency in domestic pressure cooker. So pressure cooker is a common appliance which is used in every homes, and it is a simple example of thermodynamics. It uses the heat from the LPG gas to cook the food faster. So in this case study, a family noticed that the cooking was taking more than the usual time. So after checking the cooker, they noticed that the rubber gasket was damaged and old. So the steam was leaking continuously. When the steam escapes, the heat also escapes into the surrounding. This means the less heat stays inside the cooker to cook the food. So as a result, the cooking time takes more and more LPG gas is also needed. So in this case study, we understand the important concepts such as system surrounding, heat transfer, energy, pressure, temperature in the simple and practical way.
So followed by Sahana and Shailu. So in this case study, let's consider the pressure cooker as a system and the atmosphere air and the kitchen as a surrounding. So we know that when the LPG is on, the heat is transferred from the flame to the cooker and then to the water and finally to the food. So as the water gets hotter, it changes into steam. So in the pressure cooker, the steam increases the pressure. In turn, it increases the boiling temperature of water above 100 degrees Celsius. So if we keep a food inside a cooker, it gets very faster. It cooks faster. And then if in case there is a damage in the gasket, there will be a continuous leakage of steam. So the heat and the temperature also decreases. And then as a result, the boiling temperature differs. So the food takes more time to cook. So as a result, the more LPG is also consumed because we need extra energy to cook the food. So from this concept, we see that the energy is transformed from the system to the surrounding, and then we have to look into the maintenance and we have to replace the damaged casket, and then this is the important thing we are seeing in the pressure cooker in order to improve its efficiency.
So followed by Shailu and Jeffrey, I am going to share our problem statement of our case study. So our main problem statement we identified in our case study is continuous loss of heat energy due to steam leakage. As we know, steam is escaping from the damaged gasket, which is told by Sahana in the introduction part, which carries a large amount of thermal energy into the surroundings. Because of this energy loss, the pressure inside the cooker is not maintained in a regular way. As a result, food takes a longer time to cook and more energy, LPG gas is consumed. As we know, in the first law of thermodynamics, energy is not created or not destroyed. It can be transferred from one form to another. So in this case, the heat is supplied by the stove, not fully utilized for cooking because of the pot damage, that is a rubber gasket we are using in the pressure cooker. So due to the leaking system, we want to improve the casket or the pressure cooker machinery to reduce the efficiency of the to improve the efficiency of the cooker. Due to this problem statement, the engineers are developing an improved version of the pressure cooker by our case study.
So, hi everyone, I'm Nayana. As we already saw the problem statement and the consequences of the problem, obviously right now we have to see what are the kind of solution that have been suggested by an engineer. So the first thing that have been recommended by him would be the replacing the worn out gasket and to cleaning the safety wall. It may be look like a common thing that we have been everyday using, but it is a simple activity that help to maintain the required pressure inside the pressure cooker. So if the pressure was correctly maintained on the pressure cooker, the boiling would increase, and if the boiling rate will increase, then the rice cooked faster and the properly. And it also reduces the cooking time and it saves the LPG fuel. An engineer also suggests that checking the cooker regularly for any kind of steam leakages and then replacing the damaged components when it is necessary so that it doesn't result any kind of consequences later. And then proper maintenance, the continuous maintenance would increase the efficiency and the safety of the pressure cooker. So these solutions will look like a small engineering solution, but even a small engineering improvement can significantly reduces the big losses and the consequences consequences we were facing in the future. It shows the importance of the preventive maintenance in the household applications. Applying thermodynamic principles helps to design the designings safer, more efficient, and the economical products that conserve energy and reduce environmental impact.
Followed by improving the energy efficiency of a domestic pressure cooker. From this case study, we learned the thermodynamic is not only limited to the industries, but is also applied in a household appliances. A simple pressure cooker operates a principles of heat transfer, pressure, and temperature. Energy conservation. When the pressure is properly maintained, the heat transferred is efficiently utilized. The cooking becomes faster and fuel consumption decreases. This case clearly demonstrates the importance of first law of thermodynamics, which explains the energy must be conserved and the efficiency utilized. It also highlights the importance of identifying systems, surroundings, and mode of energy transfer. As engineering students, we understand that small design improvements and regular maintenance can lead to significant energy saving. This case studies teach us how thermodynamic concepts can be applied to solve real-life engineering problems and improve the efficiency of common household equipment. Thank you.